Okay, I think we can continue. So okay, seems that everything should be fine. Okay, let's continue. Yes, I just had a small typo here on the sub. Yes, I just had a small typo here on the subclass. Yeah, as so we considered. I'm sorry, questions from you. Let me check. I'm not sure where am I having these questions. Oh, okay, I think it should be fine. Oh yeah. Okay, so let's continue. So yeah, as we can see, there is so if we consider if we look on the subclasses, then we need to just check the instance of themselves, and here you can see that the protected attributes can be used inside, which is pretty makes sense for subclasses. But yeah, it's not possible to access and even modify the um, is it still a problem for? I think this should work. Stream should work fine now. I think the link should be fine. Okay, let me maybe share it once again. Just oh, I'm sorry. I accidentally shared it with Maritomi. I'm sorry. Just put it in the wrong chat. I'm so sorry. Okay, let's continue. Let's continue. So we are pretty clear now with access modifiers. Let's move on. So there are variables. So at any time have some specific which have the specific value during the execution of the program, right? They are defined and referred using their type and identifiers. In first position, at first position, you will see the access modifier. In this case, it's the default one, for example. Then we have a type. In this case, primitive type integer, int, and then we have the name of the variable. And yes, for variables which are used as the constant, there is the final keyword added before the declaration, and in this case it will be used as a constant, and it won't be possible to change it during the execution of the program or in any other place. Yeah, literals or constants are constant variables reserved, and you can write it as well, like numbers, characters, and true or false, and so on and so on. And yes, difference between variables and constants. Yes, by convention, variable name starts with lowercase. Yeah, if name consists of several roots, they are separated by, for example, you can write the camel case, like you start with lowercase, then you go with the uppercases as well. And constants, yeah, usually we declare constants as everything in uppercase, and separate some contents. Let's call it like a content inside the name with underscore. It's pretty simple, but once you declare the constant, you need to provide the variable, which is obviously, if you want to use a constant, you need to have the variable for it, right? Yeah, as I already mentioned, there are several primitive data types in in Java, yes, it's integer numbers like byte, short, int, and long. The difference is the possible values for them. They're different. We'll talk about them. Floating point numbers like float and double with some digits of the non-integer part of the number, like 2 point something, for example. In this case, the float and double need to be used, right? Then there's a single character, like in this case it's char. Right? If we have a single character, and the boolean, the simplest one, just have two values, true or false. Yeah, let's start with the integer numbers. Byte, short, int, and long can be initialized with three forms of literals, with decimal, octal, and hexadecimal. Okay, we already discussed decimal the same way. The octal can be used, like the octal number is, yeah, as we already discussed. The binary system, decimal system. The octal is a system where the 8s are used, like, for example, like 7, equals 7, for example. In this case, it's 7 times, no, 1, 7 times 7 in power of 0 plus 0, or not 7 but 8, sorry, that's since that's octa, it's 8, right? 0, 8 in the power of 1, and so on and so on, right? And the result, you will have the value in the decimal format, right? Pretty straightforward. And the hexadecimal is the same in 18, despite the fact that it is used in a different way. Let me show you. It's a bit complicated to give an appropriate example here. Let me search for hexadecimal number system, and I can show you a small image here. And here you can see there's okay, it's a bit complicated. We will not discuss it here. Just note that it's written in actually in the same way, but for 9, for 10, 11, 12, 13, 14, and 15, it uses A, B, C, D, E, F letters. Right, that's a bit complicated. We'll not go deeper here. It's not really important for us. Yeah, for example, this one is written in hexadecimal, and this one is written in octal form. Yeah, here you can see there's the example. Like 11 times 16 power of 3, 11 times 16 power of 2. That's in 10, yeah. And same about 10, yeah, A it's 10, B it's 11, and C is 12. Like in this case, and just pretty same as with binary system and decimal as well. Right, floating point numbers. There are two types, float and double. By default, value with simple number value is double. Subtype of signed file can be set explicitly using postfixes F for F in uppercase and F in lowercase. Let me show you. For example, this here. We don't need it anymore. Like we have float a equals, for example, to f, right? We have, so if we don't have f, it will work same way now. We can use 2 point, okay, sorry, 2 point, for example, let's say the point. As you can see, it works fine. With f, lowercase, it works fine. But if we don't use, if we don't use f letter after that, it will not allow us to initialize it. Right, the same about double tap. Okay, not sorry, not D, but oh no, yeah, that's fine. D in lowercase, D in uppercase, it works fine. If we don't have it, it's fine as well. For double it will work. For float it won't. Right. Okay. Then the exponential form. If we have big numbers, like large numbers with lots of digits, then we can use exponential form. It will work fine. Right. In the same way, we can use it in E in uppercase and E in lowercase. That's the same. Okay, that's pretty clear. Let's move on. Char, maybe the simplest, the most simple, and data type in Java. It's just 16-bit Unicode character. Yes, you can see some examples. Just a simple letter, and what you can do is you can write a Unicode character. So how the Unicode characters work, let me show you. For example, I think I had the note here. Okay, let's, for example, show Unicode characters, for example, right? I think there was a nice table for them. Okay, Unicode system, yeah, this. And for example, here you can there was a table here. Okay, I think, but yes, it's Java Unicode table. You can search for it. In case, oh yeah, that's the right one. What I was talking about. So, for example, if you want to add some specific character to Java, you can, for example, select an empty set, and here we can see there's a Unicode number provided. Just copy it from here, for example. Let's write, and you can just do it this way, like, for example, in our case, we just want to print it out. Print ln. Here you need to add that slash, and what you can see, that's an error. Why? Because this symbol is used as the escape character. Yeah, and every letter here must be in lowercase. So /u, that's fine. What's the problem here? Okay, you just do it. String, for example, a equals. Okay, I think maybe. Oh yeah. Okay. Yeah, that's fine. You didn't need to use plus here. So write just test, and you can see that this this character is printed. Just see. So this is the way you can use Unicode, and yes. Okay. Let's move on. Yes, logical type Boolean. That's pretty straightforward. There's nothing much to discuss. It's true or false, one or zero. From the programming point of view. And here you can see there are some examples. We don't really need to go through them. If you want, you can go through them. I'll share the presentation with you. You can just go with all these examples. It's not really important now. Okay, so yeah, you can see that there's typecasting. If you want to change the type of the original value, in this case it's 217. If you want to short it to short variable, you need to use the cast operator. For some cases you don't need to use typecasting. For some cases you don't need to use it if the larger, let's call it the larger type is cast. You need to use when the larger type is casted to shorter type, and you don't need to use it if the target variable is larger than the source variable. So in this case, if it is in opposite side, like if you cast short to integer, you don't need to use the cast operator. Right? Okay, we can check this example in Eclipse. Right? Like for example, if we have okay, not now. Okay, that would be a bit complicated. Let's skip this. Let's skip this, but yeah, just to know that you can check how the different types work here, and know that will work in different way. And yes, this is the original size, the available size for all the types. Right, you can see that they have different ranges, different kinds without Boolean. That's kind of specific kind of value, just true or false. And it's not precisely defined by Java specification. Every other variable, the date types are defined clearly. The default values, as you probably know, that by default everything should be 0, or for objects, object references, it is null value, and false for Boolean. For all others, it's 0. Comments in Java, there are different types of comments. Let me show it. Okay, this. So the simplest one, just a basic comment. If you want to comment. Yeah, that's a simple comment. You have 2 slashes, and you can add the comment for a single line. For multi-line, it's this way. If you start with /star, for example, in this case we have multiple lines, like a equals a plus 2, for example, it doesn't really matter. And we want to add multiple lines. Here we add the start of the, like, this is the start of the comment, and this is the end of the comment. Right now we have the comment code. And this is considered as a formatted block. Why? Because there is no such stars added inside. It means that it has a strange format, like you can just do whatever you want here. It's like a bit messy, but if you format the code like Control Shift F, you'll see that it turns to formatted comment. Right, and another type of comment is documentation comment. Documentation comments. Let's write something. This is documentation comment used for documentation. How can it be done? You can press on the class and export. Right here you can see Java. Here's Java doc. You can select this one. Select the code you want to export. In my case, I'll just select the folder from the desktop I already created. And next, I think there's nothing more I need to select here. Finish. Let's construct. Okay, that's since I already have it, it doesn't really matter. So we go to desktop, and we can see that there's the documentation created. Right here, we can, as for all web projects, we have index file, and here's the documentation created. So we have the class, which is documented. I named it comments. Right, it has the methods, voids, and here you can see there's the main void, and here is the comment we just written in the code. Right, yeah, this is pretty much it for comments. I think it's pretty straightforward. Let's move on. Yes, difference between decoration and initialization. And yes, first of all, variables can be declared without any assigned values to them. But yeah, the ID will warn you about it, that it's not initialized. If you use the variable which is not initialized, you can get an error or an exception, right? And for example, you declare two variables without initial value, so you just declared variable, two variables, and here you declare the float variable with the initial value. Here, pretty straightforward. So that's the declaration. That's the declaration plus the initialization, right? Okay, typecasting for primitive types. Yeah, sometimes it's necessary to do it. We'll talk about primitive types here, but when we will talk about object-oriented programming, we will talk also about the casting of the classes, which is much more complicated from my point of view, for casting of objects. But in this case, you see that we want to, as I already mentioned, we want to pass the value of one type to a different type, which will not work sometimes, especially if you want to pass the variable which cannot be, let's call it, cannot be accepted but by the target variable. In this case we need to use, in some cases it's possible, in some cases it's not possible to use the cast. Well, let's imagine if it's possible to use the cast, we can use it, right? And here we can distinguish cases where it's not possible to cast to, but for example in the first case it's possible. It's automatic casting because integer value can be casted to integer. Yeah, long integer value can be casted to long value, so you don't even need to provide the type to which it needs to be cast, since again the shorter value, in this case integer, is shorter than long, it can be casted to long, obviously, right? Then we have the big value, and the bigger value cannot be casted directly to the short value. Why? Because it is possible that the value will be bigger than it's possible to accept, and in this case the value will not be the same, and it can make some complexities for the code. But if you provide the casting operator, so you consider that there can be some issues with the correct value. In this case you can provide the casting operator. In this case again it's incorrect, but if you provide directly it's correct for integer values. Right, again caveats. Again about typecasting, let's talk more about it. So boolean can be casted to any other primitive types, since this is the most simple type. Char can be casted to any other primitive type, which is also pretty clear. In general, value can be casted if number of bytes for value storage on left side, yes, it's equal or larger than for value on the right side, as I already mentioned. So yeah, imagine we have char value here, and yes, we can pass it to integer, but in this case it will hold it as the Unicode character. Yes, the double can be default, can be than float. If we have if we want to pass double to integer, we need to consider that it will reduce some digits, right? And yeah, in this case, if you want to cast long to double, consider that some decimal point will be lost here as well. Yes, variable scope. So there can be different variables can be located in different places. Like, let me show you in Eclipse. So for example, if we have the class, it's possible was in different places. Like here we just declare the variable inside the class as the global variable, private integer like variable a. Let's initialize it as 0, for example. And here you can see it will be available here, right? And like if you have a different block, like a different void secondary, for example, we have int b here. It's obvious that we cannot access b from here, since it's declared inside different method. same if we have another block of code here. You can see here this one. You'll see that we cannot access C here, for example. We don't see outside the block. So you can access the variables inside the block and not outside of them. Right, yeah, it's pretty straightforward. Hope you understand it, but in case you have any issues with that, don't worry. Just ask the questions and we'll try to solve them. Right, okay, let's move on. We have half an hour left for today, so okay, let's move on. Yes, inside the method, inside void, inside the class. Yes, static. We'll talk about static method, static voids and variables later. And yeah, some examples of scope. Have outside the void, inside the void. But yeah, another point is that these can be different. The variable, if you declare, for example, a variable I inside the method and outside the method, to distinguish them, you need to use this pointer. If you don't use it, then it will take the variable which is declared inside the method. If you use this, it will take the one which is declared inside this object, like in this case it's 1. Right, and so yeah, the result will be in this case 4 plus 5. Right, yes, and here you can see that the same is here. Yes, keyword static. What does it mean? It means that the static variables, you can declare them in static variables and methods. You can declare them inside the class. Okay. Most usually, statics are declared with the modifier public, access modifier public, and for static variables and static voids, you don't need to create an instance to deal with these variables, right? And these methods, so you can, for example, if you want to, like if you have 0, for example, okay, yeah, sorry. Okay. For example, you want to change the variable, it's not possible since the instance of the object is not created inside the static. In this case, we're in static method, right? And we cannot access or change the variable since there's no reference where this variable can be used. But yes, we can access a static variable here because it's static. We don't need to. In fact, just consider, just for you to understand it correctly, static variables and methods belong to the class, and instance, in this case it's instance, instance attribute belong to object, right? In this case, it's a static void and object is not created, so we don't have any object here. That's why we cannot access the instance variable, but we can access instance attribute. And to write more ceremonial, and the way I like to do it more, is that we pass the class name here. So path class name dot something, in this case dot a, and we can access private attribute, and same way we can access private method, right? For example, public static method, for example, right? In this case we can access yeah, turning times the public void string, just missed void method, and we can access static method. We can access it this way, but from my point of view it's better if we access it this way, right? Okay, but if we remove static, it won't be able to access, because there's no object, right? So again, you can access instance variables only using the objects. So instance variables and methods belong to objects, but static methods and variables belong to the class itself, right? And you don't need an object to deal with them. Okay, let's move on. Yes, static attributes, as I already mentioned, can be declared this way. We'll talk later about the better way to use static or instance attributes and methods. We'll have a huge topic on it, don't worry. So yeah, more about static attributes. Yes, they are accessible using the class name I already mentioned. Static methods, quite the same. They can be called without the creation. You cannot call the method it's just an instance method if object is not created, but you can call the method if it is static, right? Very straightforward. Yes. Again, there's an example how you can call the static method, as I already described. Yes, we'll talk about object-oriented programming a bit later in more details. Another point of Java language itself is so-called, I call it like static constructor. We'll talk about constructors a bit later, but yeah, as you already know, okay, maybe let me start with it this way. So Java and most of other programming languages do have like constructors to create the classes, to create objects with a reference to the class. So, and in this case it's like a simple method. So this is the constructor, right? It does not have any returning parameters here. So this is the constructor to create the object, right? So once the object is created, once the operator new is called, this will be triggered. And here we can just do a simple initialization. Here we can access the W, because that's an instance method, and even more we can use this, which points us that we are referring to the current object. Right, so this is the method. This is the so-called instance constructor used for every object, and we can use the static constructor, which can be declared this way. So here, as we can see, we cannot change any instance variable since it's static again, but we can change the static variables inside the class. So this is the static constructor. It will be called once. Yes, it's execute only once the class is loaded. So it will be called once during the execution. And yes, are often used to initialize static variables. This is the example. So there's a static variable. Here is the static constructor. So this way we can do some stuff without the creating of the object. Right? Okay. I will share the presentation with you so you can check it out yourself. Conditional statements. Yes, you can see there, as we already deal today, there are some conditional statements. There are different in Java. So like this, I already mentioned that if we have an expression, so here this one. Yes, all the expressions. Expression 1 should return true or false, right? If true, the first one. If the second one is then if false, then the second. Then in this case, the third expression will be executed. And it can use return value of expression 2 and expression 3. The return value should be the same. Right, assignments. So this is the simple assignment operator. We stay forward. Is variable. An expression on the right side. You can do the way that you have multiple assignments on the same statement. So it's fine. You can just assign the values for the several different variables on the same statement. Yes, the statements to control the flow of the program, of the execution of the program. So they can be control branches and cycles of execution flow. Branching statements, cycling statements, and conditional statements. We'll talk about them. So yeah, the branching statements is just simple if, else if. Right, so this is the general syntax. First we go with if true, then this one executed. If, in this case, second if is not needed, but else if use on the second place if we have some other condition to be processed, or otherwise go to else statement at the end. Pretty simple. It's pretty straightforward. Let's move on. So the switch statements. Switch statement. So again, it's pretty simple. We have a switch. We have an expression. So if expression results to constant, you need to consider that there should be constant variables, constant values on the case statements. So if we have a statement, we have expression inside. So we have an expression with the value. So if the value is constant 2, then this statement will be executed, and we use the break to go out. Right, so this one is executed, we break and we go out. Otherwise, for example, if we have the constant 3 return, then we do this statement. After that, again, the break is executed and we go out. Otherwise, if the expression 1 returns something which is not constant 2 and constant 3, then just go to default one. It's like other and others. So this one, default one, and go out. So yeah, break is necessary to exit from the switch, from successful match, and not check other cases. Otherwise, if there's no break, it will check other cases as well. Right? So yes, there's a C-like for type of for cycle. So that's the simple one. We have for cycle initial expression. Like in this case, it's for I starting with 0, and the second after the semicolon we provided the boolean until the boolean expression is reached. So in this case, we're just saying it until the while I is less than 10, and what we need to do during every iteration is we just need to add 1 to I. And for starting with Java 5, you can use you can write for cycle for loop in different way. In this way, right? For example, we have an array, or the array of strings, like free variables, free values, dot, nuts, and barrels. And the same way as, for example, in this case, it could be write for I equals 0. Next one, I is less than 3, I plus plus, and in this case, it would be system out print ln string, not string, but values I. But in this case, so with this syntax, we can write in the way that what we do, we declare the variable value here with the type of string, and with this operator, we point that do it for all values, and yes, in every element in each iteration will be passed to value, every element of values, right? So it says as do for all values, and for each value from the array that will print out the value. So this is the syntax for Java. Yeah, the while statement as well, pretty straightforward. While expression is true, do the statement inside the block, right? In this case, we can write the cycle like 10 times. The same way, start with while if condition, if condition is true, then go inside, do the statement, finish it, and go back to while. Again, if it's reached, go inside, otherwise go out. Pretty straightforward. Let's move on. Yes, in addition to while, you can use do. So it means that it will be executed at least once. So for the first time, it executes do. Then, it executes for the first time and checks if it's still needed to be executed using the statement expression, which is inside the brackets written next to while. So in this case, it will execute do despite the expression written inside the brackets of while. Right? That's pretty straightforward. Let's move on. So statement break is needed to exit the cycle. In this case, for do, you can execute it if condition is met, for example, in this case. but you can create your own construction and break the cycle when you need it. It can be used for do while, for cycles as well, and for every cycle, for every type of cycles it can be used. Statement continue as well can be used for cycles if you want to go to the next iteration. Just for example, you have the code inside, and like you check the expression inside the code, and the expression is met, and you want to. It means that, for example, you want to skip the statements located after this if block. You can do it by using continue for this exact iteration. It will go to next iteration if you want so. Right, but it does not break the execution of the cycle. It just goes to next iteration and interrupts the current one. Okay, then the reference variables used for the object as the objects classes most for the classes. So we have the class, and we have the object which is referred to this class, and yes, also called reference type variables. Yeah, again because they're referred to exact place. And let me share you maybe not just a small illustration of the references and the reference variables. So, like for example, here we have, let's call it like some stuff like object. Here's the object. Not the best way. Like here's the object. Point of view, it's better to visualize it in the way that this is what is outside. This is the reference, right? And what's inside, that's the object. So this is the object, and this is the reference. Once we accessed the reference, we can do whatever we want with the object. It is important to understand to know the difference between the stuff located inside the object and the reference of the object itself. But we will work with it. I hope you will get it once we'll be working with it. Right. Yes, so when the variable constant object is defined, reference variable is created with points to null. Yeah, that's the default value of the object. And yes, just to know that every class is inherited from the class object, right? And yeah, this is the base object class. It's also not like object, but it's also a class, which is the base class for all the classes in Java. So yeah, just know the small difference between these two things. So there's an object like object, and there's an object like the class, name of the class. Okay, so yeah, this is the simple example. You need to call the constructor, in this case with the statement new, which creates you the object. So in this case, for string, it can be done in two ways. Let me show you. Okay, we don't need this anymore. For string, it can be done both ways, like string a equals ABCD, C, for example, right? It's fine, let's just print it out, just to be sure that everything is fine. So in this case, it is assigned as ABCDC, but and same like let's go more ceremonial way, we can write it in this way, and it will be the same for this, just for the strings. it's like small exception for strings. Yeah, that's the same way. So it's pretty simple. Just to in this case, you understand that you consider that string is an object. It's not a primitive data type. Right? Sorry, that's not the way I want to do it. Okay, we are pretty close to finish today. We will continue on Friday with this topic, since again this is a huge one and it's not really possible to cover it during one session. Okay, maybe. Okay, let it be the last one. So yeah, this is the example. Reference variable. Yeah, this is example. Reference variables do not store object value, but address to the object. So again, as I mentioned here, we have a reference outside, which is available like in simple way to other parts of the code. But inside this, but with the reference, we can see that inside, like not inside the reference, but yeah, inside this area which is accessed by the reference, inside there is an object with the values and all this stuff, right? Yeah, so in this case, this is showing the smallest example. We have a class point x and y, and if we pass this variable to q, pass it, and then we can clone it to r, clone it to another new variable, and yes, if we change so in this case, if we change the variables inside the reference of, okay, let's just, okay, I'll just explain you. So in this case, these two variables will have the same reference. I mean, q and p will have the same reference, and if we change the attributes inside the p object, yeah, p object, it will have the same changes inside this one. So we have changes this one, we'll have changes this one, since this is the object and both of them have the same reference. So in this case, we just pass the reference, we don't pass the values. But in this case, we just clone it, so we pass all the values and it will remain the same. Right, I think let's stop here for today. I think we'll continue with this topic on Friday. I think there's something more to discuss here. For the home task for you would be that you just go through these simple examples. I will share this part of presentation with you. So just check all these examples. For those parts which are not pretty clear for you, you can check your own examples. I mean, you can create, you can test something, and just check if it's clear for you or not. If you have any questions, obviously you can ask me as well. Right, thank you very much for your attention today. Have a nice evening today, nice tomorrow, and let's meet on Friday. Right. Thank you.